So we are going to go over the problems from the univariate data that I talked about last class from the workbook, 1, 7, 11, is that 14 or 19? 19, 21, 31, and 38. Anybody look at those and have a question specifically, just for time reference? We wasted a lot of time getting the smartboard set up and whatnot. Is there any for sure that you'd like to go over that you looked at, you weren't sure how to do? Or do you want me to just kind of pick and choose the ones I think might be the most important to review? It's up to you. I don't care. Davis? I do? Sure. That's perfect. I'll say the answers so you can check your answers. Number 1 was C. Number 7 was also C. Number 11 was E. 19 was B as in boy. 21 was also B as in boy. 31 was C as in cat. And then 38 was D as in dog. So based on that, did you want to go over any of the problems? So we'll pick these 4 to look over, and again, we're just referencing the questions from the actual exam book. So in question 1, it's a very basic question. I don't have a copy of it up here, but we can talk about it. We have 2 different box and whisker plots. We have sedans and SUVs. I'm just going to kind of do a little sketch of the 2, obviously not exactly drawn to scale, but you get the idea. That looks about where it starts, and this one goes along, something along those, okay? So it looks a little bit like that. We'll not worry too much about the scale right now. And it just asks you what's actually true and what's happening here. So first thing you want to notice is that when you are comparing, and I don't think it's very obvious in the way I drew it, but the SUV box in the picture on the actual problem is much longer than the sedan box. Would you agree with that? Okay, so that's important information. If you remember back to box and whisker plots, what is it actually showing? What kind of information is it showing? You could just raise your hand, after school. It's a set of data, be more specific. Not the mean, the median, the quartiles. So we're talking about percentages, right? We're talking about what percentage of data is from here to here? 50%. The middle 50% of the data is the actual box itself. If the box itself is very elongated, like it is with SUVs, what does that mean about the spread? It has a bigger spread. Would you agree? And the more tightly knit, like the sedan box, its middle 50% is smaller. So it has a smaller spread. Remember we talked last after school session or during session 1 about IQR as a measure of spread. That's Q3 minus Q1, and that's really what that's measuring, the length of the box, if you want to think about it from that perspective. So it's going to ask you about spread. Which one has a bigger spread? Okay, so we're going to say that SUV has a bigger spread. What about, remember when we describe distributions, what 3 things should we be describing? Spread, shape, and center. So let's talk about shape. We talked about spread already. What about shape? And I'm not sure if this clearly shows, but in the sedan box and whisker, this whisker is shorter, or the first quartile is a shorter whisker, whereas the fourth quartile is a much longer whisker. Would you agree? And the SUV, the box, the median is not quite in the middle, so it's going to show some skew there. Would you agree? So what about SUVs? Which direction would you consider it skewed? Not negatively, we don't say negative, but you're thinking in the right direction. We just use left and right. So what would you say? Skewed left, okay? So we're going to say skewed left. And then sedans, It may be a skew right. I mean, it's slightly skewed right because the box on the right, not the way I drew it, but the way it is in the picture, the right-hand side of the box is a little bit longer and a longer whisker on the right-hand side. Again, look at the picture in the book, not on my picture, okay? It's more accurate in the book. So it's slightly skewed right, maybe. More symmetric for sure than the other. Would you agree with that? Okay. All right. So we'll say slightly, maybe even more relatively symmetric, but it's slightly skewed right. All right, so we have shape, we have center, we have shape and spread, and we need center now, okay? And what are we comparing in box and whisker plots for center? But where in the box? Which line? I see lots of lines. The middle of the box, or the center line of the box. Not always in the middle, because it won't, especially not here, but it's going to be this line for both boxes, okay? What can we positively say about center? Which one's bigger? The SUV has a bigger median. Not only does it have a bigger spread, but it has a larger median. The median is above the whole 50. I mean, the median of SUVs is almost 100% above the whole data for sedans. Wouldn't you agree? I mean, it's that far ahead. Okay, so let's look at our answer choices and see, when we're talking about shape, center, and spread, which one of these best describes, in terms of the answer choices, what we're looking at here. So it does say negatively skewed in here. Yeah, that's why you said it, Davis. I have never seen that. This is just were some interesting. All right. That's why you said it. That makes sense. But this is the first time I've ever seen positive skew and negative skew. It's always been right and left, but we'll go with it. So if you look at the best here, it does imply that C would be the best answer, okay? Again, right implying positive and left implying negative, according to what they say. Now, I hate that they talk about the range, because range is definitely not something that is emphasized in this class. But in terms of range, from a box and whisker point, what are we looking at? What is the range? Is the box the range? No. What is the range? The length of the entire line from end whisker to end whisker. And if you look at sedan's whiskers, from end to end, it's entirely encapsulated between SUVs, right? So it's much shorter than it would be. So the SUV range is larger. It has a bigger spread. So that's why C is the best answer there. Okay? Interesting that it went over negative and positive, but I've never seen that. All right, number 11. I think number 11 is a good question to look at. I'm not going to try to reproduce those box and whisker plots because they won't they won't look right. But I want you to look at comparing. Well, I guess I'll try to draw it. If you look at comparing box and whisker plots, and that's really what you're doing, try to draw it the best I can. It's not going to be perfect, but you'll get the idea.
Abby Cooney, please come to the main office. Abby Cooney, please come to the main office.
All right, so I'm going to draw, doing the best I can to draw these boxes the way they should be drawn. These are our 4 box and whisker plots for English, history, math, and chemistry. And it's asking you to rate the performance it says, his advisor decides to list the 4 classes according to how well Larry performed relative to his fellow students. And yes, absolutely. And so Larry had, I'm just going to write his score. Larry had an 84 in English. He had an 88 in history. He had an 86 in math. And he had a 92 in chem. So what should I really be looking at here to be able to decide where, I guess I need to put a scale on these two, don't I, at the bottom? So the scale here, this is 70, this is like 75, just looking here, 80, 85, 90, 95, 100. So it's along those lines, right? Okay, so what I'd like to do is to be able to figure out how he did. Did he do better or worse or what have you? Okay, so which one did he look at best in? So 84 was where he is. I'm just going to put kind of a dot on it to show where Larry is on each of the graphs, okay? And so then we have 88. About there, we have 86. And again, these aren't exactly to scale, but you get the idea. And 92. About that, okay? So again, you're going to have to do it more exactly on the graphs that you've provided. So it looks to me like he did the worst in which class? English, because he's in the third quartile. Would you agree? Or he's in the lower 50%? Does that make sense if I say it that way? So we can see that this is going to be the last. So I'm going to rate them in order. So that'll be the fourth one that we list. So we can look at all of our answer choices and realize that English is last and only D or E in my answer choices. So you can cross off A, B, C, and D. I'm sorry, A, B, and C. Question?
If it's on the line, like here's the graph, it's on the line.
On the median?
Not on the median, but first Q1.
Did I draw it wrong? Whatever. Yeah.
But like, would it be part of the next quartile, or would it be part of the quartile?
If it's on the line, so tell me where, so I can answer your question.
Right.
This one?
Yeah.
So this is on. This is it's actually not. It's between the lower 25% and the next 25%. So in order for it to be a quartile, it's the middle. It's not in either of the two. Okay? Remember how when we find the quartiles, you actually average those numbers if it's not a number that actually falls in there. Okay, so it's the middle number. Okay. So anyway, we're looking at only answer choices D and E right now because we've eliminated A, B, and C. If we keep going, it looks like history is the next because it's actually the way I drew it anyway, on the median. And it's really between math and chemistry. Would you agree with that? Okay, question. Because if I look at my first three choices, it doesn't end in English. The first three choices ended in history. Because it says it wants you to do it from best to worst. And so I know that he did worse in English because of where he falls on the box and whisker plot. Okay? Okay, so now I'm looking at math and chemistry. And we have to really look here at kind of, maybe I didn't draw it exactly to scale. So we really kind of want to look at on here, because I didn't draw them exactly right. It looks to me like math is more on the median or closer to the median if you drew them on your workbook, and chemistry looks like it's more further to the right a little bit. So I would do this and this. Okay? Again, my pictures weren't exactly to scale. Okay? Interesting, though. Oftentimes, they don't have you actually look at a person and put them in there, but they'll have you compare the actual distributions themselves. If you were asked to say which class, just in general, not looking at the person or not looking at the red or green at all, just the blue things, which class as a whole performed the best? Look at your workbook, probably again more clear. Which class performed the best? And how would you make that decision? Go ahead, Davis. Yeah, if you look at the median, if you're just comparing medians, it has the highest median. It does not have the highest spread, so that's good news. And can't you say that the first quartile is, it's above all the other first quartiles for sure? Wouldn't you agree with that? The first quartile is above the median for math. Which one did the worst? Which one's obviously the worst? Math. Biggest spread, lowest middle. Yes. That's what he said. Oh, you said history. He said chemistry. Okay, I thought you said chemistry too. You did say chemistry. Okay, all right. I heard chemistry. Okay. Anyway, it was chemistry. All right, let's look at 21. Okay. Question 21 is talking about comparing three histograms. And again, when you're comparing histograms, you want to look at shape, center, and spread. But let's look at the question. The question says, in order of preference, what is the best statistic in the list? So it says the best first. That is a weird question. Let me read it again. The distributions of values of three are thrown in the graphs. The three statistics are to be listed in order of preference with the best statistic first. What is the best? What is considered best? Okay, here's what they're going to be asking you to talk about. I believe what they're saying. So we were looking at the best one. It does say the true proportion of the parameter is 5. So they're probably saying which one best represents that parameter of 5. And so let me just, okay, that makes more sense to me. So what they're looking at here is I'm just going to kind of just quickly sketch what these look like. It looks like someone's giving you the finger, but you know what I'm trying to say. All right, so these are all 5. I tell you, my mind goes in the gutter sometimes. You get the idea. And then this one, again, was kind of tall, but it had a little bit bigger spread. Wouldn't you agree? I don't know, something like that. That's approximately what it looks like. Okay? What they're trying to say in a very wordy way is which one best describes 5. So this is really talking about the central limit theorem and not just histograms. Remember in the central limit theorem, this became much more, remember when we divided our standard deviation by the square root of the sample size, and we ended up doing that over and over, and we got our histograms to get smaller, and our spread got much smaller, and it approximated the true parameter much more closely. So because that's what it's saying, this is the best choice. Uh-huh. Oh, the center is not even around 5. So that's the worst. Yeah. Okay. Yeah, so it's not even around the right number, right? So that's going to be the worst. This is the best, and that just leaves this one for the middle. No, because the spread is not as tight as the second one. Yeah. When you're trying to best, because if you read the question, it says the true value of the population parameter is 5. If we're trying to best approximate that, you want the smallest spread as possible. And that's the key. And hopefully I have that as the right answer. Do I have 2, 1, 3 as the right answer? Did I get it right? Okay. All right. And then the last one we're going to talk about is 31 before we get to our bivariate data. And then question 31, we are looking at, it says, after a successful year, a company decides to increase all of the salaries of all of its employees by 5%. Which of the following will not be increased by 5%? This goes back to what we did during that summer assignment, first week of school, When you add something to every value, what changes? When you multiply something by everything, what changes? Do you remember that back from week 1? Okay, let's see if we do remember. So let's kind of make a little chart, okay? There's 2 scenarios, when you add or subtract or when you multiply. You have different things that happen. And we're talking about what happens to the measure of the mean, the median, the spread. Was the measure of center, the measure of spread. What else did we look at? Anyway, we'll just kind of just talk about it. So you either have the mean, the median, the range, I think we did standard deviation, and IQR. By the way, while we have this out, tell me why the mean and standard deviation go together and the median and the IQR go together in terms of center and spread. The IQR is a measure of spread. It's Q3 minus Q1. Why do those go together? Remember how when we talked about shape, center, spread, when we're describing those things, and I said, okay, I am given a median value, or I can find the middle. Why would I use IQR as the measure of spread? Because it's the middle of the quartiles, or just the middle of the 2 halves. I've got the median already, okay? Mean and standard deviation go together. So if you're using the median to describe center, you will use standard deviation to describe the spread. All right, so if I take everything, okay, so this is going to be center and spread. Okay, what actually changes when we add or subtract versus when we multiply? Remember how we had those little whiteboards that we drew on and we all lined up in a number line at the front of the class? And I said, okay, everybody add the same number. And we kind of said, okay, if everyone's adding the same number, we all just did this, didn't we? We all moved up. So what changed? Did the middle actually change? Yes, it did. The middle, so if the middle was, pretend like my arms are my spread, okay? My middle is my lanyard, okay? And if I go here and I say, wait a minute, we're going to add the same number. Everybody in this group is going to add the exact same number. We're all going to move together. Isn't my lanyard moving too? So the middle actually changes. So it changes when I add or subtract. The middle will change. Okay? It actually changes by the exact amount that you're adding or subtracting. Okay? When I multiply by the number, what happened to my arms? They spread out too. Would you agree with that? So when I multiplied, the spread changed, didn't it? But the center also changed, because the center, my lanyard would have moved too. So actually everything changed. The only thing that didn't change is the spread. When I add or subtract, my arms did not move, right? It stayed the same. So if it has a check is what happens when it moves. Which one of these is, in terms of measure of center, is resistant to change? The mean is not resistant. The median is less resistant. If I added 1 or 2 samples to the sample size, the mean's going to change, especially if it's an outlier, right? The mean is affected by outliers, the median not so much. Okay? All right. So based on this, if I increase the salaries of everybody by 5%, is that an add or subtract situation, or is that a multiply situation? It's a multiply. You're multiplying by 1.05 if I increase by 5%. If your percentage increase means you are multiplying by 1 plus whatever that number percent is. 1.05 is what you're going to multiply by. So what changes? Everything. Okay? So hopefully that's what the answer is that was provided. So Oh, what was not being changed? Okay, that's a good question. So what is not being changed? Would the mean change? Yes, the mean would change. Would the standard deviation change? Yes. I don't, hang on. Okay. Would the median change? Yes. Would the IQR change? Yes. So based on all of the things I have up here, the only answer left is the variance. The variance has to do because it's the square root of the standard deviation. So let me just read what the answer is that they wrote, okay? It says increasing a quantity by 5% is increasing as the same as multiplying by 1.05, which is what I said. So if we denote that it's 1.05x, mean are all multiplied by that, they both increase. However, since the standard deviation is multiplied by 1.05, the variance will be multiplied by 1.05 squared. Aha, that makes sense. All right, I understand what they're saying. So the variance is, so all of these are multiplied by 1.05. Would you agree? That's how they're all changing. This is being multiplied by 1.05 squared, which is not 1.05. So that's why the answer is the variance. It still changes, but it's not by that number. It's not 5%. It'd be whatever that 1.05 squared is. Okay? So that's why it's the answer. Huh? Because if you're increasing, you're adding it to 1. So that's where the 1 comes from. If it was a decrease of 5%, it'd be 0.95. So you're either adding or subtracting your, right. In just a second. It doesn't change by the same constant. So all of these have a constant of 1.05. This one's 1.05 squared because the variance is a square of the standard deviation. Will also not change. Yes, good question. All right, anything on this before we move to back to 19? Sure, with 19. Let me just look at it real quick. It is. Did you put the time in list 1? This is a cumulative relative frequency. So this is an ogive situation. Okay, so actually if you look at problem number 19, do you even remember what this word means? I know. So let me, hang on, let me show you. I'm just going to draw real quick what this is so you can kind of see. You have time 16, 18, 20, 22, 24. It's not presented this way, but to me I have to have a visual to be able to see. And then you have up here all the way to what? All the way to 1. And it's broken down, I don't know, 9, 8, 7, 6, 5, 4, 3, 2, 1. And you're just going to create a dot. Oh, I missed one. No, I didn't. Okay. So I'm just going to kind of create my own little ogive here. So at 16, we're at 0. At 18, we have 0.075. Then we have 0.26, 0.5. You see what I'm doing here? Whatever. It's eventually going to look like that, okay? It's going to be your ogive. It's asking for the interquartile range. In an ogive, do you remember how we did that? How do I find Q3? Q3 minus Q1 is going to be 75% minus 25%. Remember what the percentage that are associated with the interquartile range. So you're literally going to take a piece of paper. If you had a picture of an ogive, you're going to go out here to 75%, figure out what this number is, and then you're going to go here to 25% and figure out what this number is and subtract them. We did that back in class back in October or something last year. But you're not given a picture, you're given an actual table. So what numbers am I looking at in the table? I'm looking for 0.75, and I'm looking for 0.25. That's why it's asking you for what could be, because we don't know exactly what it is. Does that help? Sort of. So 0.75, somewhere between 25 and 26. Would you agree? So I'm going to say 25. If I look at 25%, it's a little bit less than 20, but it's definitely closer to 20 than it is to 18. Wouldn't you agree? So I'm going to say it's about 5 minutes. What's the closest to that? B. Is that the answer? Was it? Oh my God. I always worry if I'm going to say something wrong. But yeah, I got it right. And that's how I'd estimate it. Yeah, you had to recognize this was a cumulative frequency situation. Cumulative frequency does mean you're looking at those percentages. Good question. Thanks for bringing it up. All right. I'd like to at least introduce or talk about bivariate data. And then I'll give you some problems to work on from that perspective as well. We have done everything with univariate data. And again, we'll do some reviewing in class as well. These aren't the only reviews that we will do. But I wanted to at least kind of get us a jump start because we only have, I think it's 6 weeks, 5 weeks from today? No. It's on a Thursday, I think. Anyway, we have 5 weeks about till the AP exam. And I think I did tell you, or at least I told one of my classes, that as of Tuesday, no more new information. Yay! That's exciting. Okay. Hallelujah, right? Can I have an amen? All right, here we go. All of these things you should be able to do in terms of, there we go, in terms of bivariate data. How can you see all the way over here? Can you see that smartboard? Y'all are better than me. Okay. Can you draw a scatter plot? First of all, when we talk about correlation and bivariate data, what kind of variables am I looking at? Univariate, the data stuff I was looking at before, was only one variable, but it was still quantitative. We could measure it, right? With bivariate data, we now have two variables, but they're both what? They're still quantitative, okay? So we have two quantitative or measurable variables. What we've been doing in class, so with the chi-squared distributions, and especially what we did today with the independence, two variables, but those are qualitative. Okay, so make sure you understand the different kinds of data there. When we talk about and so a lot of times an AP exam might say, what would be an appropriate display of the data? Okay, and actually one of the frappies that we're going to do next week, which neither class has done, asks you to create an appropriate data display. And that's an older question on the AP exam. They've kind of gotten away from having you actually create the graphs. A lot of times they'll give you the graphs and ask you to interpret it. So they've kind of gone away from, no, they haven't done it in years, which means they'll probably do it this year. But historically, it's been about 8 years or so since I can remember that they've made you draw your own. But clue on why we would do a scatter plot to quantitative variables. And you need to label your axes, make sure they each have their own appropriate scales, and then clearly draw in your dots. We are looking, in statistics anyway, if you get to advanced math or HL math or SL math or even algebra 2, you look at whether data could be quadratic or whether it could be exponential or things like that. We're strictly looking for a linear relationship. We do, in statistics, if you remember, sometimes we take the log of one and the log of the other to kind of straighten it out if it's not already linear. We'll get to that next week, okay? We're not going to do that today. But we really strictly are looking for linear. when we're looking, remember with shape center spread is what we did with the univariate data. What acronym did we use for bivariate? Do you remember what kind of things? It was something like what? SOC, sort of. SOCS, S-O-C-S. Do you remember that? SOCS. What does SOCS stand for? Shape. Outliers. Huh? Is it center? Correlation? I don't remember what S stood for. I'm actually thinking. I don't think it's still spread. Basically, you're asking yourself, is it linear? It's either yes or no, it's linear. Okay, that's the shape. The outliers, we're going to be looking at those on the graph, and the correlation. I'm kind of thinking to myself, I've got to remind myself what the last S meant. This was a new acronym that I learned during the testing last year, or when I graded last year. Anyway, I'll go back and I'll figure it out, and I'll remind you. You can look at your notes and see if you remember as well. But basically, you're asking yourself, is the data linear? You're going to answer that question, yes or no. Is the data linear? Are there outliers? What's the correlation? You really want to be drawing a scatter plot, and what's the other plot you should be looking at? There's two plots. What, baby? All right. Okay. That's fine. Thank you, though. Anyway, back to scatter plot. Scatter plot, and what's the other plot? Oh, my heart hurts. No. No. Residual plot. Right. So with bivariate data, two quantitative variables, you want to be looking at these two plots. Okay, histograms are really univariate again. They're back in what we did before, one variable stuff. With a scatter plot, if it's linear, what should it look like? If it's linear, it should look like a line, right? We should be talking about a linear situation. What should the residual plot look like? Scattered. Okay, there should be no pattern to the residual plot. What is a residual? Well, time-wise, we're probably going to have to come back to that. But I want you to be thinking about, we're looking at, you should be being able to determine correlation. By the way, never by hand, okay? Correlation should be something that your calculator gives you. On your calculator, do you remember? Because I will have to reset your memory on your calculators before your exam. The default is not to have the correlation turned on. So you will have to turn it on yourself. The diagnostics on. So that's important. You will need to turn that diagnostics on because it will not automatically be on. Because again, I have to go through while you're lined up, reset all of your calculators, and then you have to go in with a clean slate, which means the default is not to have the diagnostics on. How do you do it again? Go to your catalog. Actually, no. You have an updated OS. If you go to mode on your calculator, I believe it's on the second page, or if you have to scroll down, it'll say diagnostics, and then it has either on or off. Do you see that in your calculators? Please tell me you do. Okay, you do. Do you with the newer ones? It's a stat option. No? Oh, goodness. You do see it now? So in the mode, you should be able to turn it on there, okay? Corinne, did you find it? Okay, good. So please remember that. And then for time's sake, I'm going to have to stop here. I do have to go pick up my own children. But we will pick up with this, looking at how do we do an example all the way through with correlation. How do I make a residual plot on the calculator? How do I find those things? What I'd like for you to do is to go ahead and try some problems on bivariate data from the review from exam 1. So let me find some of those to do. So on the 2 different exams, these are on both part 1 of each of these exams. These are the multiple choice questions on both examination 1 and examination 2. I've given you 3 problems of each. 5 of these 6 problems do deal with bivariate data. Problem 12 on exam 2 is an ogive question. Much like what we talked about before, I just wanted you to look at one with an actual ogive presented to you, okay? All right, thanks for coming. We'll see you next class.